Hi everyone. So the goal of this video is to look at energy conversion. I want you to be able to explain the law of conservation of energy and explain how energy is transferred. So the law of conservation of energy, that's a law that means that it applies everywhere in our universe as far as we know. And this law says that energy is never created or destroyed. It just gets converted from one type to another. So we can't create energy. Energy is not destroyed, but there are many different situations in our world where we can see energy be converted from one type to another. And here's just a few examples that we see on the left here. So we have chemical energy, like from food that we eat. There's all these different molecules, and our body breaks down those molecules, and we can use those molecules for energy for our muscles, and we can do some kind of motion, like what we call kinetic energy. Radiant energy or solar energy or electromagnetic energy, whatever you want to call it, can be used to keep plants alive, and they can do photosynthesis, and they're pretty much doing a chemical reaction to kind of use that sunlight and turn it into, well, really use that energy to make sugar. We have chemical energy from like gasoline that can be broken down to make our cars move, and then electrical energy can be used to do almost anything that we want in our house, like make our stoves cook our food. So again, all of these are just examples of energy being transferred from one type to another, but it's not created and it's not destroyed. Here's another example. So if you want to Google the FET Energy Skate Park, you can kind of play around with this. But this is a little simulation um, that kind of shows a person skateboarding down a ramp, and then so they can kind of like go back and forth on this ramp. Now, right now, when they're at their highest position, they have a lot of potential energy. Now, if you watch the last video, you know that potential energy is related to a position, like position of an object. So this person is really high up, and so because they are high above the ground, there's some height there, and they have some potential energy. Now they don't have any kinetic energy right now, so it's kind of like they're not moving, but they're up at the top of the ramp. Now let's say they start rolling down the ramp and they get to this bottom position, and that's what this picture over here is showing. So here they're in their bottom position, and now this is where they have all kinetic energy. They have no potential energy because they're not any like height above, there's no height above the ground. Like they're on ground level. So there's no potential energy. It's all kinetic. And one key idea here is that all of this potential energy over here got turned into kinetic energy over here. There wasn't any energy gained or lost. It just got converted from one type to another. And that's a really important idea for this. So again, if you want to play around with it, feel free to play around with this little skate park simulation. And that's just one example. There's another very simple example of a pendulum. So when a pendulum kind of swings back and forth, it's slowly going from potential energy to kinetic energy and then back to potential energy. So if we were looking at this pendulum here, then and let's maybe start at, I don't know, there's like A, B, C. Let me start over here on the left though, because I'm going to work left to right. So let's say we have this pendulum over here and we let it go. Well, if it's over here, then it has potential energy. And if we're holding on to it, then it's not moving and it doesn't have any kinetic energy. So at this point, it has potential energy, but no kinetic energy. Now, when we let it go and it swings, it's at its lowest possible point. It can't go any further, it can't hang any lower. So, this is where there's no potential energy, but all kinetic energy. And again, a key idea here is that the potential energy that the object had here gets turned into kinetic energy when it's at this position. And then as it continues to swing back up to this position, it has, again, potential energy, and for a split second it stops, and at that moment it has no kinetic energy because it has no velocity. So it swings, it stops for a split second, has potential energy, and then it swings back to this middle point. So it's kind of going potential, kinetic, potential, kinetic, potential, and just going back and forth. So again, energy is changing from one type to another, but the total amount of energy does not change. If there was no friction, like no thermal energy, the skater from the last picture would be able to skate back and forth forever. And kind of similarly, if there was no friction, we could swing a pendulum back and forth forever. Now, unfortunately, the real world does have friction, and so if you go to a skate park and you skateboard, you can't just kind of go back and forth forever. You kind of have to put in some effort to make yourself go back and forth. Or, for example, for a pendulum, if you let it go and let it swing, you'll notice that it doesn't swing as high, and eventually it'll slowly come to a stop, right? There is some friction there. There is some thermal energy that, our kinetic energy and our potential energy is slowly getting turned into thermal energy, and eventually that's all there is, just thermal energy from friction. So, of course, we don't see in the real world because there is friction in the real world. So, some things to ponder. And some of these might be useful to think about as you work on your project, your energy project. Can you even create an energy device if energy cannot be created? Some people say that during any process, some energy is lost as heat. Is this accurate? And if some energy is converted into thermal energy, why hasn't our Earth gotten hotter over the past billions of years? If we have all these processes going on and all these different energy conversions, and for a lot of them, some energy leads to thermal energy, wouldn't that mean that our Earth should be getting hotter with all this thermal energy being created? So, things to think about, and I hope they don't keep you up at night, but things to think about. All right, we'll stop here.